Thank you, Upender, for coming in and saving me. What I did, folks, is I recorded the video for Flip twice. Flip and Phil on my screen look very similar to each other, I suppose. And you're going to notice that this video, Phil, the one you're watching today, hello, is launching at the same time as another video for Flip, because I recorded it twice with two different people. And so Upender is a good friend of mine, and I called him and said, please, can we just do one challenge so I don't miss any, because I have never missed any yet. And so that's what we're doing today. So it's kind of like just a one-off challenge. How you doing, Upender? It's been a while.
Yeah, I'm good. Yeah, it has been a while.
Yeah. So, all right. This one is Phil. So you don't, like before, you don't see the thing that I'm reading right now, but Phil, it says Phil is a common JavaScript function. Now let us implement it with types. So there's Phil, there's a T and an N and a start and an end. So T is like the input, N is a thing that we're going to be filling in, and then it takes a start and an end. And then it says all of that. Okay, so start and end must be integers greater than or equal to 0. In order to simulate a real function, the test may contain some boundary conditions. I hope you enjoy it. Thanks. That's like, usually they don't say encouraging things like that. It's kind of nice.
That was a very personal description.
So here we are. We see that when there's an empty, for A1, when there's an empty array, nothing happens. All right. And even if we pass in a bunch of parameters, nothing happens. Great. If we have 1, 2, 3, and we have a 0, but we're going to fill from the 0 to the 0, nothing happens. So this is an indication that this is, I think it's that the framing would be that this is, the start is inclusive and the end is exclusive. So because this end here, yeah, I think that's how it works. There's one that's really good. I actually changed one to make it more clear here. This one, A8. I think this is the best one to look at. So we have 1, 2, 3, 4. And then we pass in true, and then we're going to start at index 1. So this is index 1, and we're going to replace the value until we get to index 3. So let me write it down here. So this is index 0, this is index 1, this is index 2, and this is index 3. So we're going to replace from 1, and we're going to replace 2, and then when we get to 3, we don't replace. So it's exclusive. Is that the? Yeah, I think that's what. Yeah.
Yep. That makes sense.
So yeah, any thoughts about that part of it so far?
Yeah, I suppose we're doing. Is this a recursive problem because we're having to kind of loop through and you can't?
I cheated. Okay. I left the
accumulator.
I saw it. Okay, all right. So, okay, I'll give you, okay, so that's the first thing. The second thing I would tell you, it's been a while since we did challenges. So these days, we've been doing them a little different. As they get harder, I give we transition more and more into pseudocode. In fact, I think the audience has seen that, but for the extreme ones, I'm almost done with all of the challenges. I don't know if I've told you in a while. Today is March 9th. It's 9 p.m. here in Eastern time. And I only have about 15 challenges left to record. We're almost done with the whole series. But by the end, with the extremes, we don't even try. The answer is just there. Some of them are literally hundreds of lines long. I recorded one the other day that was 500 lines long for the one solution, just one. So yeah, and so as they get harder, we start so what I'll do is I'll do the grunt work for you of the setting it up and let you direct me. So anybody who's watched so far has seen this kind of thing. So we have some kind of thing that's going to go here, and then we have an accumulator. So I'll give you that much that there is going to have to be an accumulator somewhere. As we recurse and hold the value. So here we're gonna we're gonna recurse somehow in here. We should probably do the constraints. What would you do for the constraints, the generic constraints for these?
The first one, I guess, just an array of unknown.
Yeah, exactly, unknown array, and then n could be anything. So there's no constraint to put there.
Start and end because the indexes, they have to be numbers.
Mm-hmm. Oh, you got it. Okay. Yeah, go ahead. Extends number. Okay, sorry.
And then accumulate. I guess what are we accumulating? I guess we are accumulating the array So that would be also an unknown. I guess you could almost make it a. Actually, no, you can't make it a generic. Ignore me.
You could do like I was thinking about it. This is like super nerdy and not useful. You could do T number or N.
Oh yeah.
Do you get that? So it's like the union of all the values.
Use that, yeah.
I don't know. I don't think it's that.
Yeah.
I don't think it's that useful. We can just go with unknown array like you had. But that's like the most nerdy way possible. So then we need. Okay. So then some of the tests, like check out this one here, A1. So A1 doesn't provide. I guess that's the spec that they want us to have. So we need default arguments for start and end.
Just be zeros, I suppose.
Yeah, 0. This will be empty array. I think it's pretty obvious.
How does that?
So I guess what they want us to do is, well, we'll come to it. I mean, I think that it's possible, T length, it's possible that they'll want us to, like, the maximum bound will be, or the end will be defaulted to the end of the array, because I think 0, 0 would mean, I don't know, is there one in here that only passes the first thing? Or only passes the start, but not the end? No, there isn't. So I don't think it's gonna matter. But like, let's just leave that as a note. Okay.
Yeah.
So
I mean, it is the T length would be more intuitive. Like start end of 0, 0 kind of means ignore me, whereas 0 to length means take the whole thing.
Oh yeah, that's a good question. Like, what happens? So there's no test case here that's like this, but has values. Okay, well, we'll see by the end, like what it looks like. Okay, so then we have to like, well, what do you think? I mean, I could say more, but like from a pseudocode perspective, like high level, what would you do next?
Well, I mean, we've got this accumulator, which is the result, but you also need to kind of keep count of where you are, like what index you're at, because you have to then check that, like your current index against the start and the end if you're within that.
Yes. So there's usually in these kinds of...
actually, would you, I guess you'd call fill, but what the way that you'd keep track of that index is by changing the start and end that you
yes,
start and end values that you pass into the recursion.
Yes. Okay. So usually,
right.
You're yes. Usually you would say like ACC length extends start or something like that, or like extends number.
Okay. Yeah.
Right. And then we have we have the branches that we go. The thing, there's a trick, and this trick that I really love, and I want to show you. I think you're going to enjoy it too. The trick is you can do, not media system access. Nope. You can do that. Oh yeah, I was going to ask you, what is your favorite fruit?
My favorite fruit right now, I think I'd say an apple.
An apple?
Because we're getting really crunchy apples. Yeah.
Oh, what kind of apples do you have there?
Oh, I don't know. I have Royal Gala. I don't know, a bunch of different ones. I don't know the different types of apples, but I just know a nice crunchy apple.
Gala are red. Okay, here we go. Maybe this will work. Hey! Okay. So nice. That's why I was asking, in case it wasn't clear. So I used to live in Massachusetts for a few years, and they had Cortland apples, were extremely crunchy and very sour, which is like...
Oh, interesting. Actually, a sour apple is nice. It hits different.
So what we can do is we built up a thing that has one more than the... So we're trying to ask the question, like, have we hit the start yet?
Yeah.
What we can do is we can add a thing there and then put in start, because start is a literal number. Does this make sense?
Yeah, because I suppose if we look at just one of the examples, if you've got an array where T is like a length of 4 and accumulator is just 0, then you haven't put anything in the accumulator yet. And we know that the accumulator and T, or the input, will always be the same length. So if you have an accumulator with nothing in it the first time, and then you add 1, and then you check, let's say start as 0, then that would not extend undefined, because if in the first loop this would be an array of 1 which would just have the apple in it.
Yes.
That's very smart. I like that.
Isn't that something? So we can do the same thing
Yeah.
here. We'll fill in the rest in a second. Is my apple still here? It is. Good. So we'll fill in the rest there, and we can I think you can guess what I'm going to type next.
And yeah,
Yeah.
because you're checking the other bound.
So we can check
If
the
you've
other
gone
bound.
above it, right?
Mm-hmm. Yes. So like in all of these cases, then all of these are recursions of some sort. So we're getting pretty close. All we have to do is fill them in. So, I mean, we're lopping off values. So for sure, like all of these fills, they're all kind of the same. They start with tail because we've taken off the head value. The end never changes. The start never changes.
Mhm.
The end never changes, the end value. All that changes is what we do in the accumulator, right? So we have to spread it, and we have to put something else last.
I see. So in this first case, it's where we have not reached the start.
Yes, it's where we have not reached the start.
And actually, are we just always putting in head? Actually, no, not always, because they will be the same thing. But
Yes.
in this case, I guess you'd put in head.
Exactly.
In this case, in this condition, we're within the 2 bounds,
Yeah.
and so you'd put in n.
Yes.
Yeah, and in this one you'd put in head.
Yes.
That's a bit strange.
Exactly. What did we fail? Did I screw something up? No.
That's the ones that doesn't have defaults. Interesting. See, now I guess this is the default. Yeah. So if you do that,
then they work.
Yeah, there you go.
Which ones were it? Were they that were failing? Okay.
These 2.
5 and 6. Oh, yeah.
Yeah, that's what you. Yeah, that's what you were wondering about.
6
Like
was what I was wondering for.
an input that has values without any indices.
Okay. So then, then it did come back to us. So that's where that T length thing happened. Yeah. That's it. Yeah, you got it. I mean,
that's it.
It's not so terrible, right?
Yeah. That was interesting.
We could probably.
I like this tactic.
Isn't that something? Yeah. It's like we just put a little value in there. This is to avoid having to make a helper for add 1 or something like that. Yeah.
Yeah. You don't. I guess you don't have to do any numerical calculations. You just use the array.
Mm-hmm. Yeah.
For that, because all you're doing is checking 1 above.
Yes. Exactly. Yes. Okay. So that's one solution. And I quite like it. There's probably, I should say before we leave it, there's probably a way, because notice these 2 cases here are the same on line 59 and line 62. So there's probably a way to put those together. I don't know. I'll leave it for an exercise for the users or the viewers. There's one more that I found, or no, there are 2 more. Okay, there are 2 more that I found. Let's do the longest one first. So this one, okay. Let's take a look. So all this stuff is the same. It has an accumulator and it has ACC length. So this is it's a little more easy to read because it uses this is valid range guy. And then we're passing in the length of the accumulator. That's all that is. I mean, I don't think we need, we could even I think we could probably just get rid of that parameter altogether. Yeah, we can. So is valid range. It used this greater than. Greater than was a prior challenge we did a couple days ago, I think. And yeah, basically we're gonna do that same check that we did there. It's greater than recurses, and it has a little counter. So we could look at that. Oops, where's the apple?
Yeah, put the apple in.
Okay, we can put the apple in there. Doesn't matter. We're never actually accessing the values of the tuple, so who cares? Yeah, and then here is they call it U, so fine. So here is the case where we're replacing, and here's the case where we're not replacing. I don't know. What do you think? What do you think about this?
Yeah, I mean, this is combining those 2. Yeah, because I guess when we were filling these in, when I was filling in what this accumulator should be, when I was doing this one, I was like, putting in head here kind of feels strange. But I suppose it's like all you're checking is if you're within or you're not. If you're within, then put in you. If you're not within the
Yep.
start and end, then put in what was originally there. And just that concept visually, when you only have one ternary, is a bit easier to read. But then, I guess you've got all these utilities that go with it.
Yeah.
This definitely reads a bit easier.
It's funny, like
more English,
I get
like
so
less
conflicted.
mental logic.
Yeah, I mean, before I started these challenges, my attitude was like, always make a helper, always break it up into pieces. But sometimes this is okay, but sometimes it's like it's almost harder when it's broken up into pieces because you have to like you have to jump around the code base a lot to like understand what's going on. Whereas like with this one, although it's a bit verbose, it's all right there in front of you.
Yeah, I think it's when you see syntax like this, once you understand what the syntax is doing, then it's really easy to grasp it. But if it's like new to you, then it's just like, what is this? What am I looking at?
Yep. Okay, cool. So let me show you. There's one more. Let's see here. Let's just comment all this out. I think this one is a bit of a mishmash. Like it's kind of like a spiritual successor to both of them. I don't know. We've looked at enough. You tell me. Like walk through it and tell me what you think about it.
So this is doing similar to what we had. It's checking if the original extend start. So this is why is it checking that? Extends.
So original is the 1, 2, 3, 4, 5, the fifth argument. So let's look at Phil. 1, 2, 3, 4, 5. So original gets changed in this case only. Seems weird to call it original.
Oh wait, original is their accumulator. Original is their accumulator. Okay. No, it's not the accumulator. It's just a duplicate. What is original?
I think they're saying like it's like the unfilled tail.
I don't follow. Like,
so,
okay, here, because it's being passed in. It's part of the recursive parameters.
Right. So like this one does not have like it's almost like it should be like this. Like this one here at the end doesn't have if we like line up the arguments a little bit, it's like that.
Yeah. Yep.
And yeah, original. So in this case, we're passing it straight through, but in this case, we're adding head. We're adding the first value of t, and t is always tail. So t is like we're like slowly chopping off values one by one of the tuple until we get to the end. Yeah. And
but here, I think what I don't follow is like when you get to here. Oh, okay. We're changing original here. Yeah, this one's
not
tricky.
Great, right?
I don't understand why you need two of these things.
Well, you don't. I mean, we saw that in the first one, right?
Yeah.
I think like, yeah, it's fun to look at these because I think, yeah, I mean, it's so cool to like have you back on and talk about this stuff because I've learned so much since we first met and we're doing some of those string challenges once we did. And one of the things I've learned is that like sometimes there are like you can get stuck down a path that forces the solution to be tough. So by using two accumulators, like we saw that in the other one, right? The other one used that we just looked at had well, it didn't have two accumulators per se, but it had sort of like two paths that it's taking, and they have it recurses, like just the greater than part recurses in a different way. So it can be hard to recover. Like I don't know how I would refactor. Like here's a good question. Like how could we improve this? I don't know. Can you think of a way to make this better?
Well, it's really understanding that. Like, do you need two accumulators? And if you don't, why do you have an additional one? And what is that trying to achieve? Like that's kind of where I'd start. And because when we were looking at this, I'm like, I don't understand what.
Yeah, I mean, I think
original
this part is saying if we haven't started yet, then just pass in the values wholesale. If we're done, then just give me the rest of their values. Like, this is a literal return. These two are base cases of the recursion. So like here it's saying, hey, don't bother looping. Like, that's one thing that's cool about this one. It stops recursing once we've hit the end of the range that we're supposed to go to.
Okay. And then it'll take the remainder or the tail and just
yes,
take
exactly.
the whole thing and put it on there.
Because T is tail by that point. T is like a chopped down version of the original. So it's like we have more values, but we know that we're at the end. Like, no need to keep recursing. Just return them all together. So we have like the ones we've done so far, the accumulator. So I think the accumulator is usually, let's see if this errors. Let's see, N array. No, it doesn't. Okay. So
actually, I suppose in this one, I think I missed this thing in here, because what I was looking at was like, well, when you have a start and end, then you're going to have three sections. You'll have the ones that are the original values, and then you'll have the replaced ones or the filled ones, and then the remainder. And so when I was looking at this case here, where it's not putting the remainder in, it's like, well, how are you getting that last little tail? But I think it's this thing here is the exit.
Yes, exactly. It's like we have the unreplaced stuff, the replaced stuff, and then like T is, I guess, always unreplaced by that point. But like, this is the cases that end. And so, but otherwise, we're just gonna keep, if we're not ready to keep going, then like we pass in our unreplaced stuff, and and then this is passing in the replaced thing plus N. So I guess what they did is they considered the stuff that's being replaced like a separate subarray, and we need to just like build that sub up array until we're done, and then we jump out here or here.
And I suppose that's an okay assumption, because it will be a chunk. There's no like they're not sort of intertwined at all. It is like, well, you've got
contiguous
the
block.
originals, you've got you'll have one continuous block. So I guess you can suppose what they're doing here is that they're tracking that continuous block separately from the other one.
Cool.
This is slightly more efficient. I got a real curveball question for you.
Sure.
Since we're nearing the end of these challenges.
Yes.
What have you learned from all of the conversations and things you've been through, and what would you do differally?
What's
one thing you would do differently?
I would do the thumbnails differently. Let me tell you what. There's some things that I really regret that were like, I'm new at this. I've been keeping track. So stay tuned, I guess, is my teaser to you. There's a couple like things that I've seen that are like absolutely wild. So I think there's like about 4 videos that I'm going to make after this is all over. They might get split up in like 4 concepts. The first is like, maybe I should name them all, but like the first is like beautiful examples, like beautiful ones that are like crazy interesting. I love these solutions type of things. The second is like things that I didn't understand very well, like intersection. I didn't understand intersection. Like, how does intersection work? Like the AND operator, like how really does it really though? I didn't get that. And I think I have a better understanding of it now. Things like, conditional, what's it called? See, I don't know what I'm talking about. I'm a big imposter. Distributivity. So just distributive unions is something that I didn't understand really, like it felt like it was iterating, but I couldn't understand how. I kind of get that now. Although I can't seem to come up with a word. So there's a bunch of stuff like that I think has been interesting. Another topic is like a video on what the point is of doing this kind of stuff. There's a lot of controversy actually on the channel and in the comments about like what's the point of doing this kind of stuff. And in fact, some of the co-hosts have been like not very receptive to the concept of like. I think this is kind of like weightlifting. It's like you don't go to the gym and lift weights because you think you're going to have to pick up heavy stuff later necessarily. It's like you're trying to build muscle and like be healthy. And these are learning exercises. So like, There's a video I have
I mean,
planned on that.
it's the process, right? It's the process. It's not
Yes.
the destination. The destination it'll show up. Like
Right.
you're just laying the path essentially.
Mm-hmm. So that's one of the videos, and then like things I think are there's another. I'm not sure I'll make a whole video out of this, but like maybe I'll do something about it, like maybe a blog post or something somewhere. Like things about TypeScript that are really powerful that I don't think people know about, and also things that are unnecessarily complicated, like doing like any kind of counter stuff, like we saw here. Actually, I mean, like any kind of those things are really, really tough to do. And I mean, I'm also thinking, I'm actually, I don't know, talking to some people, we'll see, TypeScript people about like talking about why some of the things are the way they are. Someone asked me the other day, like, how come you can't just like put an if statement in there? And it's like, well, because like, why do they have to use, they said like, why do they have to use ternaries so much? There's all these ternaries all the time. And the reason is because ternaries are expressions, and there's no like statements in TypeScript's type system. You can't make statements. There's only expressions. That's why we're using recursion everywhere. We can't loop. We have to use recursion. It's the only tool we have. And it's because there's no syntax. And they're like, well, why can't we just make a syntax? It's like, well, we could, but like that would radically change everything, because like going from no statements to statements is that's like, now we're a very different thing. So it's like almost like this is like it's powerful enough to do crazy things, or like wild and things that you wouldn't usually need, but sometimes library authors need. And that ties into the first thing. Like this whole challenge and this whole channel basically is like library authors central. This is not, I don't care about making content that like is applicable to everyone. I'm actually way more interested. That'd be nice if I can, but I'm way more interested in content that doesn't exist today for like library authors, or like people who have to be doing this kind of people who are looking at code just like what's on the screen here all the time. Those people have no resources to learn this kind of stuff and get better at it and like learn the ins and outs, because it's like it's not documented on the TypeScript docs. There's just no learning tools. The challenges are the best thing I've ever seen, and so like that's why I was passionate about making this video series and getting people and talking about it. Is that it's like
it has a big rundown effect, because when you look at like really well-made libraries like React Query, for example, or any other ones, I'm just name dropping on your channel
TRPC,
when you look at these and you're I guess as a web developer using TypeScript, you consume them, but when you're those library authors that are not developing in TypeScript, but they're kind of developing with TypeScript, it's like a slightly different mindset. Every time I've like all the challenges that I've done with you, and just in my own time as well, when you're looking at this, it's like you kind of have to understand how to do this in TypeScript, and it is slightly different to how you would consume like this. It's I don't know how to put it, but it's like it's almost like a different language, but not like quite. It's the same stuff, but and so I guess even to those people that are kind of questioning like why do this, maybe they don't really realize that this is what's having the impact on their day-to-day development. Like this is the guts. I almost feel like
if you watch just anyone listening, like if you watch these videos and you think like, what's the point? Just unsubscribe or something. Like I don't want to force the channel is demonetized. I don't make any money from this. It's not like I'm not offended by people not finding it interesting. It's not for everyone. It's not that kind of content. But the people who find it fascinating, like I don't know if you saw it Upender. We have a video I'm super proud of. I didn't do it, but someone came to the meetup and talked about like a very deep dive on the TypeScript module resolution, like how it works. Like it was an hour long, like very brutal, like investigation of the deep details. And I just love that content exists, because not very many people need to know that stuff or are interested in it, but the people who do need to know and are interested, the library authors that do need to get into the weeds of how this stuff really works and understand it like head to tail, those people,
Yeah.
it's like gold to them. And I love providing that because it's not anywhere else. How do I know? Because I've been doing this kind of stuff. You have too, you know.
I know you're this person that likes to go right down into the weeds of it. So
yes.
I can see it. Yeah.
And even not, I mean, I've been surprised and flattered. There have been people on the channel who have said like, I don't even write in TypeScript, but I just like watching these things to see what's possible. And it's like, wow, that's great. That's a whole other set of people that, you know, benefited for just out of curiosity. So, you know, it's not for everyone, and I'm totally cool with that. I'm not interested in being like a influencer, or it's like not a popularity contest for me. I'm just hoping that I feel pretty confident that the people who need this information will find it here eventually, because there's so little of it out there already. So when they search, I'm basically all that will come up for some of this stuff. And that's by design. It's just an underserved part of the TypeScript world, and I'm trying to fill in that void a little bit. And there's so many great people. To those listening, Matt Pocock just released his Total TypeScript. Have you seen any of this up under?
Not recently, but I do watch.
He released this course on this TypeScript course, and it is absolutely phenomenal. I mean, it's like the best. I'm so glad that he's doing that and working on that, and it's really important. It's an important thing to be doing. And like, I'm just really happy that that space is being served too. But like, you know, there's like only a couple hundred maybe, or maybe even less, like maybe 100 people in the world who like really need to know everything there is to know about how Infer works, or how, you know, these things. Like, it's never going to be a large crowd that cares about this stuff. So like, okay.
Yeah.
It's fine.
Well, I for one am grateful for you.
Thank you.
Actually going through this process. And yeah, I mean, a lot of people might also not know the effort that goes behind this. So I've definitely seen it, and it's impressive.
It has been a little bit.
Yeah.
But I'm going to make it. Thanks to you.
Nice.
I have not missed a video yet, and I don't think I will. I think we will get to the end. It's going to be around June. I didn't factor in when I gave the original date with March 20th. There are new challenges being added all the time. So it's going to be more like 150 rather than 140, I think, by the time we get to the end. I'm going to wait until like late May, and I have someone teed up to like do the last ones that have happened since the beginning. And then we'll be all set with the whole series, and I can stop spamming everyone. I feel so guilty. Is this weird? I feel so guilty for spamming everyone's YouTube. You know, like it's just like videos every day. I get that it's a lot, and I wish there was a way to. It's like 150 videos. I can't. I can't do it any other way. If I spaced it out, I would be years. So
yeah.
Oh well. Well, thanks for coming on. Thank you. Thank you for asking about that stuff. It's fun to talk about, and maybe it's. I'm just excited to get through all these challenges.
Yeah.
It's fun stuff.
Yeah, I'll be looking forward to those additional videos that you hinted at. Those will be quite interesting as well. Yeah.
Awesome. Well, thanks again, man.
Cool.
We'll talk to you soon.
Thanks. Have a good one.
Cool. All right.